Here's video help for problem 15.3. We're thinking about two coils, and this is very common. There are all kinds of multiple coils in modern day experiments. And I've got a particular voxel that I'm imagining, has a signal picked up by both coils. Say one picks up a signal, voltage of A, and the other one will be alpha times A. Some fraction perhaps. This is a smaller coil and farther away. And we might say that the noise for the two coils would be the same, that each one, actually if they were similar size, they pick up noise from all over, and suppose that noise is pretty much the same. Well, we have to talk about the variance in the noise, because remember that as we're measuring noise, it averages out to zero, and so that the appropriate thing for us to analyze is the variance, and actually the RMS, the root mean square of the noise. Well, I've got myself a situation then where the total voxel signal, will be S1 plus some beta times S2, because I'm free to combine this however I want. Actually, just imagine that I'm going to take it. I got a number here and I got a number there, and I want to try to figure out what's the best way for me to combine these things to get the biggest signal to noise I can. It certainly isn't, I can't imagine, beta is not going to be arbitrarily large, because beta also affects the noise. That is, my noise, we used eta for noise notation. I've got noise from coil 1 and noise from coil 2. Remember their variances are the same. And I've got to combine them then with that same beta. Okay, what's important is signal to noise, signal SNR, and we want to make it maximum ultimately. So I start out, I've got the signal is S1 plus beta S2, and S2 is alpha A. And the noise, I don't want to write everything out and spoil everything. The noise, is the RMS. So I'm taking the square of this, averaging it, no cross terms. So, you're going to get something squared plus something squared. And at the end of it, then you can factor out A and sigma 0, and you got a function of alpha and beta. And that's what we're going to use in part B. Let's find what beta we want such that this is big, such as its maximum. In chapter 28, this is really crucial, because what you're going to find is that the maximum signal to noise is just taking sum of squares, and the square root of that. Sum of squares. And what beta does that correspond to if you just take sum of squares? Well, in C, we imagine, say, perhaps the noise isn't the same, so you'll just replace sigma 2 equals sigma 0, the noise not being the same, but take sigma 2 is beta prime times sigma 0, and then put that into this, and calculate out what maximum value of beta then for a given beta prime and given alpha you would get. What's the beta is what you are going to just arbitrarily choose in your scheme to combine these signals. And in the written homework, I tell too much. I give you the answers.